started. Okay, guys, so today we're gonna continue what we learned last week. So we're first gonna go over the homework that you did on quizzes. So we're looking at some common mistakes, and then we're gonna go over logarithms and logarithm operations. Then we will do a Kahoot that everybody likes. And yeah, you guys will have homework. So let's get started. Did it move? Yeah,
Okay.
my laptop is being a little laggy. Okay, so we're gonna go over the 3 most missed questions on the homework. And if you want to go over anything else, you can just ask us.
Yeah, we're gonna always make the homework due on Saturday, because if we make it due on Sunday, then we don't have enough time to go through the points and give you guys points for the rankings. So it's always gonna be due the day before class.
It's gonna be due at 3 p.m. on Saturday, so keep that in mind.
Should I give everyone the Jamboard link?
Sure.
Okay, here you guys.
For this one, yes, the answer was C. Well, yeah, we'll go over it. We'll give you a second to come on here. Apparently somebody can't get on.
Onto the meeting?
Or the Jamboard. Oh, the meeting. Well, I don't know why that would be the case. Am I not letting them in? Is that what's happening? There's no one in the waiting room right now, so. And as for the homework, we'll send out a reminder this week for you guys, since a lot of you guys are saying you didn't know it was due yesterday. Okay, so I guess I'll explain the first one. So number 9 is to simplify the exponential expression, and it's the quantity of 2x squared y to the 4th to the power of 3. So if you remember from last week, whenever we have like a power to a power, you can multiply the exponents. So here, wait, what? Okay. So we're gonna split this up into like separate parts. So 2x squared times y to the 4th is just 2 times x squared. Cool. That's a 2 times y to the 4th, right? So now we can like distribute this power into here. So then it's 2 cubed times x squared raised to the 3rd times y to the 4th raised to the 3rd. Then now we can just simplify. So 2 cubed is 8. X squared to the power of 3 is x to the power of 2 times 3, which is 6. And finally, y to the 4th power to the power of 3 is y to the 4 times 3 power, which is 12. So yes, a lot of you guys said it was C, and that is indeed the answer. Any questions? Okay, let's go to the next one.
Okay, so number 8, simplify the following expression, 16 raised to the 1/4 power. So for this question, you have to remember what fractional exponents do. So fractional exponents are saying what number multiplied by itself 4 times equals 16. So this is what the 16 to the 1/4 power is asking. What number multiplied by itself 4 times equals 16? So you could also write that as x to the 4 equals 16, and we want to find the x here. So that would just be 2, since 2 times 2 times 2 times 2 equals 16. So that would be A.
All right, and our third question. So this one is asking for 10 radical 6 plus 2 radical 6. So this one, you would need to know how radicals work. And if you remember, oh, wait, what happened? Okay, if you remember from last class, you can treat radicals as like variables. So when you add, like, let's say instead of 10 radical 6 plus 2 radical 6, I had 10x plus 2x. Then I just have to add my coefficients together, right? So 10 plus 2 is 12. So 12x would be my answer. And it's the same thing for this actual question. So I see that the radicals are the same, and then I just add my coefficients together. So 10 plus 2 is 12. Then I put my radical at the end. So the answer is C.
Okay, so those are just the 3 questions we're going to review. Are there any other questions that you guys want us to go over? And if so, just put the question in the chat because
Yes. Somebody wants to go over the next slide. So are you saying this one? 5 squared.
Yeah. On the quiz it said the answer was 15 power 6.
Oh yeah, that was a mistake, but we fixed it now.
Yeah, I was a bit confused with that too.
Okay,
Yeah.
so
We fixed it.
that makes sense why some people missed it then. Yeah, it's 5 to the 6, not 15 to the 6.
Yeah.
Okay, side 5. We'll go over this one too. So this one was a little more confusing, I'm guessing. But so basically, it's asking for the cube root. And the cube root is like asking you for, actually we'll do it this way. So the cube root is the same thing as raising this expression to the power of 1/3, right? So that's how fractional exponents work. So like the to the power of 1/2 would be the square root, power of 1/3 is the cube root, and so on. So here, if we rewrite it this way, we can split it up into 64 to the 1/3 power times x to the power 6 to the 1/3 power. Then the cube root of 64 is 4 because 4 times 4 times 4 is 64. And since this is a power and the power, we can just multiply. So 6 times 1/3 is 2. So x to the power of 2. So our answer would be 4x squared, which on here is C. Any other questions we should go over? No? Okay. Let's go back to our slides then. All right.
Oops.
Oh, wait.
Oops, it got moved. It's supposed to be
Okay.
after the logarithm stuff. That's okay. You
Wait,
can
I think the slide
escape.
is gone.
No, it's misordered. You can just escape and I can fix it.
All right.
Okay, I fixed it now.
Okay, I think I might need to reload mine then.
Okay.
Sorry, my
So
laptop's being laggy.
yeah, you can just present now.
Here.
Yep.
Okay, there you go.
So we're gonna be learning about logarithms today. And how many of you guys know what a logarithm is? Or yeah, just if you know what it is, what it does.
I've heard of it in coding.
Yeah. Okay, that's good. Most of you guys are going to be learning something new today. So logarithms, well, they're very closely related to exponents. So like logarithms are just another way to think about exponents.
Wait, I'm
So
sorry, but does it show a blank slide?
yeah,
Okay, so
click it again.
okay, right now.
Okay, there we go. Okay, so logarithms are just another way to think about exponents. So when we have like a regular exponent expression, we have like for example, 3 raised to the 4th power equals 81. And what that means is that it's 3, but multiplied by itself 4 times, then that equals 81. But now I can change the question. So now we can ask 3 raised to what power equals 81? So in other words, we want to know how many times 3 needs to be multiplied by itself to equal 81. So to ask that mathematically, we write log, which is log, and then we put a little 3 next to the g. And then in parentheses, we write a big 81. So that is basically asking 3 raised to the what power equals 81. And that equals 4. So to read this, we just say log base 3 of 81 is 4. That's a little bit confusing, but just think about it as 3 raised to the what power equals 81. So that's essentially what the logarithm says. It's like exponents, but backwards.
Mhm.
So now we can go over a few examples. So let's say we have log base 5 of 25 equals 2. Kyung, you can use the annotate tool if you want.
Okay, wait, somebody says they can't see the screen.
Oh,
I can't see. It just has examples.
yeah, it just says it's a blank slide.
Okay.
So let's say log base 5 of 25. So first, what does that mean? Like, people type in the chat, what does that mean? Like in words.
Means how many times can 5 be multiplied by itself until you get 25?
Yeah,
Yes.
exactly.
Mhm.
So how many times does 5 need to be multiplied by itself in order to get 25?
Yes, so yeah, 5 raised to the power of what equals 25. That's good. Okay, so it's like asking actually this. And we're trying to find x.
Yeah, the answer would be 2, because 5 has to be multiplied by itself twice to get 25. So 5 times 5 equals 25. Okay, we can do another one. So log base 3 of 9 equals, what does that mean in words?
And then how many times 3 to the power of y equals 9?
Mhm.
Yeah, exactly. And what is the answer to that?
2.
Yeah, perfect. It's 2, because 3 raised to the 2nd power equals 9.
Great. Should we do one more?
Sure. Let's do log base 4 of 64 equals what? So what does the log base 4 of 64 mean in words?
That means 4 is raised to like what? Okay, 4 raised to what power equals 64?
Mhm.
Yeah, that's exactly right. So 4 raised to the what power equals 64. So that would be, as a lot of you are putting in the chat, that would just be 3, because 4 times 4 times 4 equals 64.
Anybody confused right now or have any questions? Okay, I think you guys are all getting it very well, which is very good. So we're just gonna look at this again. So here, the number at the bottom, the small number is called the base, and the number you're trying to get is the argument. And your answer would be the exponent you need. So we're asking, like, what exponent does the base need to be raised to in order for it to become the argument? So if you don't know those words exactly right now, that's also okay. And one thing to keep in mind, so this is like a rule for logarithms, is that the base has to be greater than 1 and that the argument must be positive. So the argument is this. And the base has to be greater than 1. And we won't go into too much detail about why that is, but if you are curious, you can find out later. why does the exponent solve itself? Could you explain a little more about what you're asking?
Oh,
It's a joke.
Oh, it's a joke. Oh my-
Okay. Wait, did the slide change at all? Oh, okay.
Not yet. Oh yeah, it just pointed out.
Yeah, okay.
Okay, so just a reminder, exponential form is when you raise something to a power. So like a to the b power equals c. The logarithm is just a rearrangement of that. So log base a of c equals b.
This
Ye-
is just reinforcing what we just said.
Yeah, or you could just think of it a raised to the b power equals c. So yeah.
Okay, so now we're gonna look at just kind of like a discussion about why this is useful. So in the chat, take a guess if you want at like why you think logarithms would be useful.
And solving equations. Like of equations like powers, you could just use logarithms.
Yeah.
One way.
And coding. Definitely coding.
Yeah. To reverse exponents, yeah.
Okay. So one useful way is that you can easily plug it into your calculator. So if you were actually thinking about, what power do I need to raise 3 to in order to get 81? If I didn't know that 3 to the power 4 was 81, I would have to do like maybe 3 to the power 3. No, that's not it. 3 to the power 5. Well, that's not it either. Then I would just do trial and error until I would do 3 to the power 4 and be like, oh, it's 81. But now with the logarithm, I don't have to do that. And I can just like directly ask my calculator what the power is and it will tell me.
And another way why it's useful is because sometimes you have weird bases where like you need to find like 2.1 raised to the what power equals like 105. It's like, even if you try to use trial and error, you would never get an exact answer. So instead, you could use a logarithm. You would just do log base 2.1 of 105. That's basically asking 2.1 raised to the what power equals 1.5 or 105. And that equals 6.2727 134. So it's a very weird number, and you wouldn't be able to get it if you didn't use logarithms.
Yep. And also problems concerning population or growth usually use log and exponents. So wait, what just happened? Okay, can you guys see that again? Because it said my screen sharing just paused.
Yeah. I mean,
Yeah,
I
we can
don't
see
It's
it.
smaller now. Okay, it's
Yeah.
bigger.
Okay, I don't know what happened, but anyways, so yeah, you'll see some problems like that. And well, this one's kind of just there for fun.
Okay, so we're now going to do a few practice problems. For the first three, you want to convert the first few to like logarithmic forms. So currently it's in the form like a raised to the b power equals c. You want to change them to logarithm form where it's asking a raised to the what power equals c. And 4 through 6 are just like the opposite. So you guys can work on those or put them in the chat. And if you have questions, just ask out loud or in the chat.
Yep. And yeah, you're not solving for anything, so you're just changing the form. Somebody says I'm confused. Wait, never mind. Okay.
Oh, also, when you're writing it, make sure you put like log base and then your number like make sure you have an equal sign and it equals something, because yeah, because we need to know what it equals.
So like I did log underscore 3, and then in the parentheses I did 9 equals 2. Would that be okay?
Yeah, that's fine.
Mhm.
Okay. So let's go over some of the questions. So for the first question, it's 3 raised to the second power equals 9. So when converting it to the logarithm, the 3 becomes the base, so the little number, and 9 becomes the big number, the one in the parentheses, because so when we're writing as a logarithm, we would write log base 3 of 9 equals 2. And again, that's just asking 3 raised to the what power equals 9.
Sorry, I'm trying to color code it so it's easier to see.
Yeah. Okay. So for the second question, the base, it's 2 to the 10th equals 1024. So the base would be the number that's being raised to a power. So this one would be 2. And the number that it equals is going to be the red number, so 1024. So we would write it as log base 2 of 1024 equals 10. And that's just asking 2 raised to the what power equals 1024. And for the third one, the base is 8, and the argument would be 4. So in other words, the number in the parentheses would be 4. And the whole thing equals 2/3. So log base 8 of 4 equals 2/3. So again, that's just asking 8 raised to the what power equals 4. And it's 2/3 because 8 raised to the 2/3 power is 4. So for 4 through 6, we're converting it into exponential form. So for number 4, it would be asking 4 raised to the what power equals 64. And since we know that the value of the logarithm is 3, that means 4 raised to the 3rd power equals 64.
Right.
For number 5, we would read it as 5 raised to the what power that equals 3,125. And the logarithm tells us that we need to raise 5 to the power of 5 to get 3,125. So we would write that as 5 raised to the 5th power equals 3,125. And finally, for number 6, that's essentially asking 2 raised to the what power equals 1/2. And the answer is -1. So that means 2 raised to the -1 power would equal 1/2. So hopefully you guys are starting to see how we can convert from a logarithm to an exponent and from an exponent to a logarithm. And that can be really helpful sometimes when, you're maybe doing a target round in math counts and you need to solve for the exponent. Well, then you can just use the logarithm on your calculator to do it instead of just trial and error.
Yep. All right. Is anybody confused about this? You can use calculators. Not on the sprint round.
Just on the target round.
Yeah, when you go to practice, Mr. Crampton will tell you about that.
Oh wait, is Mr. Crampton still the math counts teacher? Or it
No,
is?
you got
Oh,
a
he's
new
not?
one this year.
Oh,
Not this year. Why? Who is it? Oh,
Uh,
Miss Lay.
who's that?
I've never heard of her. She's new. Oh,
Oh wow.
that's
I
interesting.
think Mr. Crampton's still helping with the math counts tryouts because I think I'm going to be volunteering at the tryouts and helping out there. But I didn't. Yeah, that's interesting. I didn't know that.
So this is her first year.
yeah.
Oh, okay.
Yeah, he was last year, I remember. I had a question.
Yes.
So with math counts tryouts coming up, do you guys have any like printouts or something of like math count rounds, like sprint rounds or anything?
You can go to the math counts website, and I think they have like past tests on there. I don't know how many they have, but I think it's like mathcounts.org, and then like I think it's like past competitions or something.
Yeah, we'll go over we can ask questions like that at the end. I think would be some on AOPS too.
Oh yeah, AOPS also has tests.
Mhm.
Okay. Whoa.
Wait, did I skip that? No, wait. That we just went over this, right?
Yeah, we just went over the answers, so it's okay.
There you go.
So now we're going to try some challenge problems. So these, it's okay if you can't figure it out because they're not called challenge problems for no reason. So just do your best with them. Think about your rules of exponents and then like think about it like backwards.
Is that no, I'm on that.
Okay, just to clarify for number 3, it's like written a little weirdly, but basically this part is the exponent.
Yeah,
This
that
entire
whole thing.
Yes. So it's b to the power of log b of x. Yeah. And if you don't understand these, like we'll explain it. They are more challenging. So
Wait, so it's b to times log b to the power of x?
no.
I mean, log b x.
So it's b to the power of this entire thing in
Oh, that makes sense.
yes. Okay.
But it doesn't.
Okay, do you guys want us to start going over them, or do you want a few more minutes to solve?
More time, please.
I know what number 1
Yeah,
to 2
4 minutes.
is just weird in my.
That's okay. We can give you guys some more time.
Mhm.
If you want, you can try to say it out loud. Maybe that will help you. Say like each one out loud. Well, I don't think it'll help with number 1, but it might help for number 2 and 3 if you say what it means out loud, and then you might realize it.
But if you don't understand, it's okay because we will explain it and you'll probably be like, oh, okay, that makes sense.
Okay, you guys still working? Or do you want? Oh, yes? Okay. Okay. I want to start going over them. So for number 1, log base 8 of 1 equals something. So we can rewrite to this in exponential form because I think it will help to actually see what it's asking for. So let's say log base 8 of 1 equals x, but we don't know what x is. The whole expression is going to equal x. So then that would essentially we can rewrite it in exponential form. So that would be 8 raised to the x power equals 1. But here's the thing. There's an exponent rule that says that when you raise something to the 0th power, it's always going to equal 1, right? So since 8 is being raised to the power and the whole expression is equal to just 1, that means x will just be 0. So the answer is 0. Okay, so does that make sense to everyone? Okay, that's good. So for the second question, it's log base b of b to the x power, and we want to find what that equals to. So we can probably say this out loud. So this is asking for b raised to the what power. So we can just say the b raised to the what power equals b raised to the x power. So what power should b be raised to in order to equal b to x?
The x power?
Yeah, it would just be the x power, because the definition of a logarithm is saying what power should be b raised to get b raised to the x power. So that'd just be x. It's sort of confusing at first, but it's sort of like self-referential. It's talking about itself kind of. But yeah, the answer would just be x. And finally, Advika, I think you said you wanted to explain number 3.
So after their tip that you should read it out loud, it kind of hit me. Since b is like your base, x is your argument, and then that would equal to, I just say y. But you don't really have to do anything since the power that you're finding, that already equals x. So like in a way you're saying b. Okay, it's very hard for me to explain, but this would just be x because log b to x would just be equal to some number, but we're just finding x, really.
Yeah, I understand what you're saying. Basically, it's like b raised to a power, right? But the power is the power you're supposed to raise b to get x.
Here, wait. So I'm gonna rewrite this. So let's first look at the thing in this circle. So log base b of x is the power, right? And I'm just gonna say this is equal to y. So now I'm gonna rewrite this into exponential form. So this would become b to the y power is x. So everybody see how I got from here to here right now? Yes, okay. So now my question is actually asking me, so I know that I set this thing equal to y. Keep that in mind. So now this entire thing becomes b to the y. But wait, we just said that b to the y is x, right? Down here. So then the answer to this entire expression is also x. So does that make sense? It might be a little confusing, but so the answer would just be x.
Right. Oh, yeah. Because like the exponent you're trying to find is b to what power, and it would equal to x. So that means b would to the b to the power of x, which is b. I get it.
Mm-hmm. So do more of you understand what's going on in number 3?
So log b x equals y.
Mm-hmm. So that's what I just set this top part to, just to make it simpler. Should I explain the same thing one more time? Would that help anybody?
Yeah, that helps.
Okay, so I'm just gonna erase some of this because it's like too messy. Okay, so everybody knows that right now this is the base and this is the exponent, right? So b to the power of log base b of x is what we're trying to solve for. So now I'm just gonna look at the exponent by itself first. So this is log base b of x, and I'm just gonna say that log base b of x is equal to y. So we don't really know what y is right now. Like we don't know what number y is, but we're just gonna represent my exponent as y, as my answer as y. So now I'm just gonna rewrite this whole thing in exponential form. So now b to the y is equal to x. So I know that's true, right? And so when we did this,
Wait, how do you know that that's true?
so right now I just rearranged this equation into this form. So it's saying the same thing, but I just rearranged it.
Does the variable have to be y or can it be?
No, it can be anything. It's just a placeholder. Like
Wait,
can make
so is the x like? But how do you use x when it's already on that side? Like, how do you know that that's true?
so let me explain further, and see if you still have the same question. Okay, so now basically I replaced this entire thing with y, because y and log base b of x are equal right now. I'm just saying that. It doesn't have to be y, it can be like a or c or something, but I'm just using y. So now my expression turned into b to the y equals something.
Oh, so x is just a variable. It's not like the x in the equation.
It's like just, they're all just like holding their place. They're not like,
Oh, so
yeah,
it doesn't have to be x. It could also be z or a or something.
yes, it can be anything.
Okay, it doesn't really relate to the problem that much.
Yeah, just for this problem, we just happen to use bx, and then I happen to use y. So now my expression is b to the y equals something. And when I do this, I'm using the same variables, right, as when I reorganize this over here. So I know that b to the y equals x, and so I just use that again here and say that b to the y equals x. So this whole thing is equal to x. Does that make sense?
So just to confirm,
Mhm.
so the logarithm, like b to the from the x equals y.
Mm-hmm.
If we simplify b, if we put the logarithm into basic form,
Yeah.
it's b to the power of y equals x, right?
Yep.
And so if we replace this entire logarithm with y, we
Mhm.
get b to the power of y equals something. So we already know that b to the power of y equals x, so we can just put x there, right?
Yeah, that's exactly it. Okay,
Wait,
Charles.
so couldn't you just do that with every problem then?
No, not really, because this one has a logarithm as a square, or sorry, power.
Yeah, it's not for
Yeah.
every single problem. It's like,
I know, but like you didn't
But I
really
guess you can say
solve
like
it
1 to
using
the power of
these two
logarithm.
equations.
I guess you can say 1 to the power of logarithm something something, or replace like maybe you can do 2 to the power of logarithm, and then some other thing like logarithm base 8 and then 1 equals something.
Okay, wait. So basically what it is, it's okay. So would it be fine if instead of x you use something like z?
yes, it'd be fine.
Okay. So but like so the x in log bx is different from the x in like the variable, the other x, right?
No, they're both the same.
The other x, which other x?
The b to the power of y equals x.
They're
This
the
one?
same.
Both the same.
They're the same.
Maybe we
Then
could illustrate it using an example. So like we could just say b equals 2 and x equals 8 and see
Yeah,
how that
okay,
works
let's
out.
do those. That's helpful. Okay, so now 2 to the power of log base 2 of 8. Okay, so somebody tell me what log base 2 of 8 is.
It's 3, right?
Yeah, so it's 3. So this like top exponent part is equal to 3, right? And now I can replace this top with 3 then, since they're equal. So now I can rewrite my question as 2 to the power of 3. But oh wait,
oh, I see now. Okay, I got it.
yeah, so I know 2 to the power of 3 is 8, like just from my memory, I guess. But also looking back, I see the 3 is over here and the 8 is over here and the 2 is over here. And it's the
Okay,
same.
that makes sense.
Yeah, okay, that was helpful. So Charles, are you okay too? Since you said you were confused. Yes, okay, that's great.
Okay, so the answer would be just b log bx is equal to x.
Yep.
So the answer would just be x.
Yep.
Okay, thank you.
Mm-hmm. Great. Okay.
Okay, Kyung, do you want to go through the properties or do you want to do some example problems?
Example problems as in like,
The ones at the end.
let's see. I feel like, what do you think, Amy? What
I think maybe we could go through a few of the properties, like the product and then like the product and quotient, maybe.
How long is this class? It ends at 4:30. Okay, I guess we could compromise a little bit then. So are you saying we should do product rule and then quotient and then skip to the problems at the end?
Yeah.
Yeah, okay, I think that's good. All right, so as you can see, we're kind of running tight on time, but we're gonna go over the more important, I guess, more basic and important rules with logarithms. So the first one we're gonna look at is the product rule. So remember how multiplying exponents with the same base could be simplified to adding the exponents. So let's see it in action. So basically 2 to the power of 4 times 2 cubed is equal to 2 to the power of 7. So right here, what I did was add these exponents, right? Remember that from last week? So now I'm going to look at that with logarithms instead. So since we can rearrange exponents as logarithms, we can basically rewrite this property as a property of logarithms. So let's see. These things are the same. Log base 2 of 16 is 4. Like these are kind of rearranged, but they're the same thing. And hold on one second. I'm going to go all the way to here. Okay. So right now on here, what I don't, 2 to the power of 4 is 16. 2 to the power of 3 equals 8. Here I have 2 to the power of 4 equals 16. 2 to the power of 3 equals 8. So they're like the same things, but just rearranged. Okay. And that equals log base 2 of 128. Okay, so now if I just look at this and I rewrite it, I see that this whole thing is 4, this whole thing is 3. So 4 plus 3 equals 7, since this whole thing is 7. And up here, they're basically using the same numbers, but in a different order. So I'm gonna go to the next slide because I think it'll make more sense if I do so. So basically what we're saying is that the product rule is when I have a to the power, the log base a of xy. Xy is like just a number. It's not like x times y, it's just xy. Well, yeah, and you can split this up into log base a of x plus log base a of y. So like xy is not x after y, it's just like a number by itself. So if I look here, log base 2 of 64 equals log base 2 of 16 plus log base 2 of 4. Because here, this is going to be my x, this is going to be my y. And x times y, or 16 times 4, is indeed 64. And now my product rule said that these two should be equal. Like when I add these two, it should equal this. So I know that log base 2 of 16 is 4. Log base 2 of 4 is 2. And that log base 2 of 64 is 6. And when I do add these two together, I do get 6. So our product rule is like proven true basically here. And like when you split this bigger number into the two things, as long as they're both like factors of my number, it should work. We're just showing you 16 and 4 because it's like easier to see. So does that make sense or like no?
What
I think somebody was talking, but they cut out. Or is it my computer?
Yeah, I think they cut out.
Okay. If you want to type your question in the chat, that's also okay.
I had a question.
Okay.
You said something about a factor. What do you mean? Like, could you say that again?
Yeah, so like what I'm saying here is, so if I look at xy, which is x times y, and then x and y. So basically I'm saying like, since x times y equals xy, that means x is a factor of xy, y is a factor of xy. So like, like how do I say this? So 64 is also 8 times 8. So let's say I instead write it like this. So log base 2 of 64 equals log base 2 of 8 plus log base 2 of 8. And so far, this is like, I think it'll be true when I look at my product rule, since 8 times 8 is 64, right? So now if I calculate this separately, I know this is 6, and both of these are 3, since 2 to the power of 3 is 8. And here, I'll go over here. 6 equals 3 plus 3. Well, that's true, right? So what I'm saying is that when you use this product rule, that the number here and the number here, like when they're multiplied together, they should equal this number over here. Does that make sense?
Yeah, kind.
Kinda. I feel like I might have made that a little confusing. You want to explain, Amy?
What was the question? I didn't quite catch it.
So I basically said like that when I use this product rule, like this big number, these two should multiply to it.
Yeah, they should multiply to it, because if you reverse it, remember that a logarithm is just an exponent that's sort of like reversed, right? So when you have 2 raised to something equals 16, right? When you multiply exponents, like say if you multiply like 2 raised to some power, then times 2 raised to another power, you add those exponents together. So the product rule is sort of saying if you add those powers, you're just multiplying their bases together, sort of.
It might be a little hard to like understand right away. And that's
okay. We
expect.
can do some examples.
Is there an example slide after this? I don't know.
No, we can do some examples on this slide.
Okay. Let's see, what should we do? We can try this one. So log base 3 of, let's do 27. Okay, so I just wrote this equation out, and I'm just gonna like see how it fits into my product rule up here. Right now, that's like where I'm at. So nothing more complicated than that. So yeah, first I need to make sure that this number times this number is equal to this number. So 9 times 3 is indeed 27, right? And now I'm just gonna see if this actually like works, if this equation is true. So log base 3 of 27 is 3. log base 3 of 9 is 2, and log base 3 of 3 is just 1. So is 3 equal to 2 plus 1? Well, yeah. So this equation is true because I used the product rule. Does that make sense?
I think it does.
Yeah, okay. Should we do another one in a different format or move on?
I think we can move on.
Yeah, okay.
Okay. So the next rule is the quotient rule. It's pretty kind of similar to the power rule, because remember that when you divide exponents, you can subtract their exponents. So like, for example, 4 to the 5th power divided by 4 to the 3rd power, when you're simplifying that, you just subtract 5 minus 3, and then you get 2. So it would be 4 squared. So that's what you usually do for like regular exponents. We can also use this property when we're doing logarithms. So for example, we have log base 4 to the log base 4 of 1024 minus log base 4 of 64 equals log base 4 of 16. So if we look at each of these logarithms individually, log base 4 of 124 is just 5 because 4 to the 5th equals 1024. And then log base 4 of 64 is 3 because 4 raised to the 3rd power equals 64. And log base 4 of 16 is 2 because 4 raised to the 2nd power, 4 squared equals 16. So basically, the quotient rule says, if you can go to the next slide, the quotient rule basically says that when you subtract two logarithms, but they have the same base, you can combine them by dividing their arguments. So log base a of x minus log base a of y equals log base a of x over y. So that's a
minus.
Yeah, minus.
Yeah.
So that's what you can use for like when you're subtracting logarithms and you want to, combine the numbers together. So as an example, if we want to like expand log base c of the expression e over d, we would just sort of like give the e its own logarithm and give the d its own logarithm and then subtract them. So does that make sense?
So could you like give an example for this slide?
Yeah, we can do that. So let's say log base 2. 2 of 4 equals log base 2 of 32 minus, okay, wait one moment. Log base 2 of 8. Does that work? Yeah, it does.
32.
Oops, 35.
Wait, I need to move this.
Log base 2 of 8. So log base 2 of 4 is asking 2 to the what power equals 4. So that would just equal 2. And log base 2 of 32 is asking 2 raised to the what power equals 32, which is 5. And then log base 2 of 8 is asking 2 raised to the what power equals 8. So that would just be 3. So it turns out that 5 minus 3 does equal 2. So this rule works, and it's pretty similar to the product rule. If you remember that multiplication and division are pretty similar to each other. And this is just using the exponent rule of like dividing and subtracting. So yeah, those are the two rules that I think we'll go over today.
And just like we're not gonna have time to actually like use these rules, but basically like you can use these to expand or condense logarithms, and you don't need to completely know what that means, but like it helps you solve problems involving logarithms later on. I'm gonna have to skip a bunch.
Yeah, you guys don't need to know all of these. Here's a fun fact. Usually, I think you usually learn about logarithms in high school. So since you guys now hopefully already have sort of a background in logarithms, you should hopefully find that high school logarithms is easier for you than compared to some other people. So yeah.
And even in high school, a lot of people get confused by this. So like if you don't completely understand right now, then that's like okay. Like it's kind of expected. How many weeks is this gonna be? Are you asking like about logarithms or is this entire course? Oh, you can't hear?
Oh, now you can.
Okay.
Basically, are you asking about like this exponents logarithms thing or the entire course?
No, the course. Yeah, it ends in January. I think
Yeah.
at the end or something.
Yeah, January 30th is the last day.
All right, so we want to get to the Kahoot, right, guys?
Yeah.
So then the Kahoot will probably take I don't know,
There's 21 questions on the Kahoot. Let me quickly add up the time.
oh no, I feel like it might take the rest of class if we start right now.
Yeah,
You
let's
could
just
do-
start now.
Okay.
You could do the Kahoot for our homework.
But that's
Well,
not as fun.
yeah, and then it'd be hard to do it like with everyone else.
Okay, we can just do a Kahoot
Oh,
then.
right.
Okay, sorry I have to like, oh wait, I already have it open. I'm sorry, that was dumb.
Oh yeah.
Wait, what do I do? Oh,
Oh, play guest or something.
since we didn't have as many like practice questions today, I think we'll just make it 3, 2, 1 for the points. Does that sound good? And you can have like something that's not your actual name for your nickname here, as long as it's like appropriate. But if you happen to place in the top 3, then you should probably like tell us what your name was so that we can actually give you a point. I'm gonna wait until 4:10 for everybody to join.
Don't put space to the person in who said they want to let you in. Like, don't put a space between the code.
Oh yeah, the code.
I'm on laptop, so it might be a little hard.
You can do split
I mean,
screen.
I'm on iPad.
Oh.
Okay, I'm gonna wait like, is anybody having trouble joining? Because I want to start very soon so that we can finish.
I'll put the code in the chat. There.
Okay,
I
I'm
think we
gonna
can
count
start.
to like 20 and get started.
Okay, so there's two
Oh.
teams. I think there's no way. 2 people just left, but I think
You can't join.
2 people are missing this time.
Why can't you join?
Yeah, don't put the space between the pin.
If that's your problem.
Okay.
Can people join as we start, as we play?
Yeah, they can join as we're starting.
Okay, so since we don't have that much time, I'm just gonna get started. Oh, do you guys want the music on or no?
I think it's
Yes.
sort of here a little
Sort
bit.
of.
Okay, I'm gonna get a tiny bit louder. Okay.
I didn't get to answer it. I just solved it. Like, because I'm on iPad, it's hard because then I have to switch between.
I can't see that
Zoom.
thing anymore.
What?
Like the
Oh.
questions.
That's weird.
Wait, what, did I do something?
It just said someone has started screen sharing.
Oh, that might just be a problem on your part.
Oh.
Anyways, this one was simple, but just 14 times 14 is 196. It's good if you have like your perfect squares until probably like 20 memorized.
Yeah, 20 is a good number to keep memorized.
Mhm.
Then you can do things like this fast.
I
Yep.
did it, but like
I don't
I said,
need. I just made a calculated guess. It can't be 392 because that's super close to like square root of 20, and it has to be more than 100 because that's square root of 10.
That's
Yeah.
Oh, Rick, I got it wrong. Oh no, I didn't.
Make sure to not sacrifice accuracy for speed.
like I said, I'm on iPad, so I have to keep
What?
switching from.
It's how is it not 108?
6 times 6 is 36. Multiply it by 6 again. And
Oh, I didn't multiply by 3.
yeah,
Yeah, if you try to go too fast, you could make like a really silly
Okay.
mistake on these.
I lost like 13 places from that one.
That's okay. You can get back up.
I'm on iPad, so I have to keep switching back and forth from Zoom to Safari. It takes a while for it to load. Can I just put the answers in chat?
you can, but you won't
I
get
mean,
any points on Kahoot
yeah,
for it.
it won't help you. You'll probably just
I don't need
help others.
no getting any points on Kahoot. I mean, yeah, I know it does take away the fun, but like,
You could private message us
Yeah, if you want to.
so you don't
Okay,
take away the
I'll do
fun. Okay.
Yep. So you can only add it. I mean, when you multiply two exponents, you can only add the powers if they have the same base. So if it's like 3 to the power of 2 times 4 to the power of 3, I can't just randomly add the 3 and 4. True or false?
The Kahoot audio is so great. It'll randomly get really loud and then get really soft.
Maybe it's because I'm sharing my screen.
Yeah.
That's funny.
Ooh. I guess like a lot of you guys must have misclicked or something.
Yeah.
I think they kind of like okay. So true or false, unless you like change it, always stays in one place. I think some people thought it stayed in false, like the tree was in false. So it started spamming it there when it was actually on the other side.
Probably.
Maybe.
Don't. I guess that's the price you pay for spamming before you see the answers.
So yeah, this one is just pretty simple. You add the exponents, so it's true. Oops, I skipped that.
Nice.
All right, so this one, you just multiply the powers together. So the power of an exponent, you just multiply. So 23 times 3 is 69. I think some people might have added on accident. Okay. Who's leading? Winner. Interesting.
The winner is leading.
Ooh, speed.
Wow. Hey, Charles, do you have a question? Your hand's raised.
That
Oh.
question got me like up. I was in 12th place before, 5 points behind. Now I'm 4 points behind in 12th place.
Okay, I'm
Wow.
glad that almost everybody got it right. So yeah, anything raised to the power of 0 is 1. Oh, change
Smiley face is in the lead.
by 8 points. Make sure you read the answers correctly.
I know I lose like some of my time just reading it.
Yeah.
I'm just kind of lucky that I did read it correctly, just because I might have almost clicked the minus ones.
Yeah, misclicks are kind of really annoying.
Especially if you're in a good place. It's happened to me a ton of times. I get so angry.
Yeah, it's a very frustrating.
Oh wow.
There was one time in class I misclicked, but the answer was like the correct answer was wrong. So like
Oh my
I
gosh,
clicked
was
the
that one
wrong.
I got right, and I was
Yeah.
gonna catch up to you. That was so
I misclicked the correct answer because the correct answer was the wrong answer.
yeah, like the Kahoot was messed up, and I was
Yeah.
like right behind her trying to beat her, but then that happened. So, oh yeah, okay. So this one, actually, a lot of people said -16, but remember, when there's a negative exponent, it doesn't mean that the number becomes negative. It means you find the reciprocal of it. So I write 1 as my numerator, then I write my number without the negative sign. So 1/2 is 1/16. All right. Oh, some new people.
The Kahoot isn't like a grade or anything, right?
No, it's just
No,
for
it's for
random
fun.
points.
It's for reviewing for fun. Make sure you think about this.
Wait, no.
Yeah, don't click too fast. Think about it.
Frick, I think I
Didn't
got it wrong.
think about it. I realized the answer was wrong. But I clicked.
Yeah.
Imagine they should make a mobile version of Kahoot.
They
They
did.
should. Wait,
Do
do they have one?
Yeah, they do.
Yeah.
Wait, I got it right? Yes.
Okay, so
What's the difference though?
So I expected that a lot of people would choose green on accident. So basically, right now, I know that 9 squared is 81, right? So if I do 81 to the power of 1/2, that's just the square root of 81, which is 9. But if I do 81 to the -2 power, remember, when I have a negative power, I write my numerator as 1, then write my thing in the bottom. So this would be a very different answer. Do you see that? This would be like a really small fraction, and this one is 9.
Okay, got it. Who is Jingbo? I'm behind them still. Even if I'm going up my ranks,
when I
I'm just
came back to the
constantly
top.
behind them.
Smiley face dropped. Oh no. Ooh, think about this one too carefully.
When are the logarithms gonna come in?
The longer one?
This one's a pretty lightweight Kahoot. There's some log problems at the end,
I
but
just guessed. I have no idea.
Ooh, could I say this one like after the time is up?
Why didn't I guess the decimal? Hey, I got it right. Guessing works.
I got it right.
it's really
Okay,
funny.
let's see if I will actually explain this. So instead of guessing, we'll see why it's actually right. So 8 to the power of 4/3. So I'm gonna reverse the like power of a power rule. I think that's what it's called. So instead of this, I know that 8 to the power of 1/3 to the power of 4. Like if I had this as my expression, I can simplify this to this, right? So I'm just going in the opposite direction and writing it this way. So now I'm going to calculate the thing inside the parentheses first. So 8 to the power of 1/3 is the cube root of 8, which is 2. Then 2 to the power of 4, that's just 16. Make sense?
Yeah.
Great. Wow, some change. Still pretty close, and anybody could catch up.
That's pretty easy.
Kyung, did your computer fan turn on?
What? What's
There's a
that?
I hear a high-pitched noise, and I think it's your computer fan or something.
It's like on
Um,
very lightly, but I could barely notice until you pointed it out.
Aren't I? Isn't 6 squared also right though?
It's the square root of
that's the
36.
trick. So
Oh,
wait, what's
it
the
would be
square
6,
root of
not 6
36?
squared.
6, yes.
Yeah.
Yeah, that might have been easy to click, but yeah, it's actually this one.
I'm still in 8th place, even if I'm like 1,000 points behind.
Oh, no change. But you guys are pretty close.
If you think about it, 1,000 points is just one question.
Yeah. If the person in front of you gets it wrong and you get it right, you can catch up.
I lost finally.
No, I'm dumb.
Uh-oh.
Actually dumb. Just saying, guys, it's red.
Maybe a lot of people got it wrong.
I feel like a lot of people might have gotten this one wrong.
What?
Oh,
Oof.
It's actually red?
Okay, so now I'm gonna try to simplify this. So, I think you guys have probably figured out that's something to do with fives, because 5 times 5 times 5 is 125, right? So I'm gonna write that in here as 5 times 5 times 5. So now, since I have like 3 5s, I can take 2 of them and take them out. So it's gonna become 5 radical 5. Because like, and if I go the other direction, like if I put this back under the radical, I would do 5 times 5, right? And 5 times 5 times 5 would be 125. So yeah, I just took out 2 of the 5s and put it on the outside. Make sense?
Yep.
Great.
Wait, did anyone actually go red?
Oh,
Because
whoa.
I told them to.
Whoa. A lot of change.
Yeah.
I don't know if we'll be able to finish. If you guys like have to go somewhere, once it becomes like 4:30, you can leave. But if you want to finish the Kahoot, I think we can just stay after a bit and finish it. So if you want to stay, that's also good. So I think a lot of you guys got this one right. But so the confusing thing is 13 times 7 is 91. But that's not how like radicals work, right? You can't just pull it out when there's only one of it. So 91 is 13 times 7, but you would have to have 2 of a factor in order to pull it out, but there's nothing. So it can't be simplified more than this. Ooh, this one was like the one we reviewed on the homework.
I think I got it wrong, but I'm not sure.
Oh, I'd forgotten about it for a second. So it took me some time.
Yeah, it's the one we just went over in the beginning of class from last week's homework.
Yeah, 100% yellow.
Harder question.
It's actually red.
Why not not behind Jingle?
Remember, when I do this, I can just replace, like think of these as variables. So instead of this, I could like pretend it's 2x plus 3x, which would be 5x. And similarly, 2 radical 3 plus 3 radical 3 is 5 radical 3. So I don't actually add what's under the radical. I just add my coefficients. Ooh, this one. Back to basics.
Am I dumb? I think I'm dumb, but I also don't think I'm dumb at the same time.
We'll see. This one's pretty simple, but then we went over this like a long time ago. Well, it's actually a week ago, but in the beginning, so. Right, so basically like the definition of a radical is that when you multiply 2 of them together, it would become the number here. So radical x times radical x is indeed x. All right, maybe the leaderboard is settling down a little bit. We'll see. Oh, this one might change it up.
Why? You like to torture us?
I thought you guys wanted more complex.
No. I mean, I never
Complex
asked
ones
for
are
it. I don't
better.
know about
Because
that.
that's when like people go down. So I'm ready for the complex ones. I'm just hoping I'm not the one that goes down.
See, I'm normally lucky, so I just guess and it normally works. And as I say that, I'm gonna get it wrong. Yep, I got it wrong.
So this one is actually the yellow one. So I'm gonna actually first look at what this means. So this has a cube root over the entire thing, 125 x to the 9th. So now I'm just gonna rewrite this radical as an exponent instead. So it's like the power of 1/3 is the same thing as a cube root. So 125 x to the 9th to the power of 1/3. So now I'm gonna like distribute this. Yeah, you guys can leave if you want to, if you like need to go, but you can stay for the
Wait, Kyung, should we do the standings based off of this question? Because then it's not fair to the people who have to leave.
Yes, you can do that.
Okay.
Yeah. Anyways, so 125
Bye.
to the power
Bye.
of 1/3. Bye guys. It's 5 x to the 9th power of 1/3. Just x does it.
Okay. I'm gonna write down the standings.
Mm-hmm.
Okay, smiley face does not count. Smiley face is that's me, so that doesn't count. Advika gets 3 points, and then Bill. So 3, 2, 1.
Wait, so you were smiley face the whole
Yeah.
time?
I got one
You
question
got
wrong.
one wrong in between. So you
Yeah, I
know-
got one wrong. I accidentally did a -2 instead of 1/2 for that square root question.
Oh wow, our teacher got it wrong.
Yeah, it was kind of dumb.
It's okay. Everybody makes mistakes.
Yeah. Okay. So Advika gets 3 points, Anne gets 2 points, and Bill gets 1 point. If you guys still want to play, we can.
Do you guys want to keep going? We have like
Yeah.
6 questions left. Okay. I think there's like about 10 of you.
This was a little hard.
Yay. So this one, I can just multiply the numbers under my radical. So this equals radical 81. And the square root of 81 is 9. Oh, answer streak of 12. That's really good. Are you not Sai? No? Yay. So we went over this kind of briefly last class, but when you rationalize the denominator, you have to get rid of the radical in the denominator, right? So I'm going to multiply by radical 5 so that my radical is gone. So radical 5 times radical 5 is 5. Radical 3 times radical 5 is radical 15.
Logs.
Today. Might seem confusing, but if you just remember, it will be fun. Great. So most of you got this one right. So remember that I can rewrite log base A of C equals B as A to the B equals C. So yeah, using that same thing, I think the question was like then.
You can click show media and it'll show.
Oh. Yay. Okay. But you can still see my drawings. That's cool. So yeah, my A was this, my C was this, and my B was this. So I just rearrange it into this format and I get the red as my answer. Nice. You guys are all getting it right. Ooh, this is similar to what we did today. One of the things, the challenge problems. Okay, so I think we had one that was like log base b of b of like b to the x or something. But this one we could just solve it. So wait. Actually no, I don't think we could solve it. I mean you could, but like
You could read it out loud. Log, it'd be like 2 raised to the what power equals 2 raised to the 8 power. That'd just be 8. So, yeah.
yeah, so this equal. Yeah. Oh, wait. Okay, we are on our last 2 questions.
Oh, by the way, this is A times B times C.
Yeah. So this, we did go over this actually.
Yeah.
Today. You would have like a 50-50. Oh my gosh, what just happened? I'm sorry.
Oh, we can still see it.
You had a 50-50 chance of guessing this because we only got to go over the quotient rule and the product rule today. But yeah, basically when you have like 3 multiplied things, you can split them up into their own logarithms and add them. So that was called the product rule. All right, last question. Oh, you need to actually do
Now
it.
we actually expand it.
Make sure you read the choices carefully. It's better to get right than, and it's better to be late than to get it wrong.
We may want to cut this at 30 seconds so we don't have to wait too long.
Okay. Yeah, I think I'm just gonna go now. Yeah, most of you got it right. So yeah, you expand it and give each one their own logarithm and add them. Great job. So let's see our podium. Bill.
Okay, 3rd place is Bill. 2nd place is Advika.
I wonder who this will be.
Smiley face is in 1st place.
Great job, guys. If you only got like 2 and 3 wrong, that's like really good.
Yeah, technically, Advika was 1st, Bill was 2nd, and was 3rd. So good job.
Yay. Hopefully you enjoyed that.
Okay, thank you everyone for coming. Have a great day.
Remember to do your homework by 3 p.m. on Saturday.
Yep.
Bye. Thank you.
Bye.
Bye everyone. Oh yay. Everyone was actually paying attention. Sometimes we have like a couple kids that are